This is the first lesson on similar triangles. Here we will discuss the concept of similarity. You see, in our earlier classes we have done about congruent figures. When do we say two geometric figures are congruent? If they have the same size and same shape. Now if you see here these two triangles, they have the same size, same shape. What about these two straight lines? They have the same length. We can call them two congruent straight lines. Similarly, these are two congruent circles. When do we say these two circles are congruent? If they have the radii same, the radius are equal. So, two congruent figures are identical or they are equal in all respects. Okay? Two figures are said to be congruent if they have the same shape and same size. Then we say the figures are congruent. Then what are similar figures then? You see, these two are congruent, they are similar as well. But here are some figures, these three circles you can see here. This is smaller than this circle and this circle is bigger than this circle. But the shapes are same. All have the circular shape, right? But the sizes are different here. The radius of this is less than this. This radius of the circle is less than this. So, here the shapes, though the shapes are same, but the sizes vary. Same thing you have with these three triangles as well. Again, we have three similar squares here, three similar hexagons here. Therefore, similarity means they have the same shape but different size. It is actually the, transformation of the figure. Transformation of the figure in the sense, the original figure is suppose is this. If this figure you see, it is shrunk by some scale factor we say. This figure is enlarged or magnified or stretched. You see, we can call stretch factor. Whatever factor it is magnified, that is called a scale factor in fact. We will study about this later. So that is why we say it is a similarity is nothing but a transformation of geometrical figure, the shape, right? I will show you more examples here. You see, now here I have an interesting thing. These two pictures are very much similar, right? They are similar exactly, but their sizes are different. You see, similar in the sense the shapes are same, but what about the size? The sizes vary. So that's why we are saying these two are similar photographs. In fact, they are, right? Then one thing here you see, we can see here Anaximander, this person is Thales, this person is Pythagoras. So in this similar triangles, you see these people play a great role. Under this topic, we'll do Thales theorem, or it is called basic proportionality theorem. Okay, so this is the person actually who has given the proof for the basic proportionality theorem. And one more thing, you know already Pythagoras. So we'll be doing the proof given by Pythagoras of Pythagoras theorem using the concept of similarity. So we have many interesting things to do in this chapter. Okay. So now right now we have just seen the persons who have contributed for this similarity. So anyway, so coming back to our point, these two photographs are similar. They are not congruent because their size is different. Okay. So come on, now let us just summarize what we have discussed here. Two figures are said to be congruent if they have the same shape and same size. Two figures having the same shape and not necessarily the same size are called similar figures. So we have similar figures as well as congruent figures. Now all congruent figures are similar, but the converse is not true. No? Yes, these two are congruent figures. Are they similar? Yes, because their shapes are same. Moreover, shapes are same but size also is same. So they are congruent. But what about these two? They are similar because their shapes are same but sizes are different. So we cannot say these two are congruent. So we say all congruent figures are similar, but the converse is not true. Now in this lesson of similar triangles, we will be learning the definition of similar triangles. You see, in the earlier class, In lesson 2, we have defined what are similar polygons. Triangles are a special case of polygons only, and for similar triangles also the same definition holds. So two triangles are said to be similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Now let us do with the help of a figure here. Let us take two triangles A, B, C, and this triangle has D, E and F. Now ABC and DF are such that angle A equal to angle D, angle B is equal to angle E and angle C equal to angle F. You see, it is enough actually if we know these two angles if you are equal, then automatically the third angles must be equal, because by angle sum property of a triangle, automatically C will be equal to F. Now I say angle A and angle D are equal, so now I have to use the word corresponding. First understand the word corresponding. If these two angles are equal now, so angle A and D are called the corresponding angles for these two triangles. These two are corresponding angles. Then angle B is equal to angle E. So we say B and D are corresponding. We cannot say B and F are corresponding, okay, because these two are equal in this. Now I will say angle B and angle E are corresponding because they are equal. Again, therefore, since these two are equal, the third angles, angle C and F will be the corresponding angles. Angle C equal to angle F. This is the first condition for similarity. So this first condition is, this is if this is the situation, the first condition is satisfied here, right? All the corresponding angles, they are equal here. Then corresponding sides are in the same ratio. So now if we take, suppose A is 1 then and B is 2, then this is say 1.5, say this is 1.5, then this is 3, and then let us take this B say 0.6, okay, this is 0.6, then this is 1.2 I will take. Because you see, to select the lengths of the sides, we have to take care that sum of the two sides of the triangle should be greater than the third side, right? Have you satisfied that? See, this is 2.5 greater than this. This is definitely greater than this. What about this? This is 1.6, this is 1.5. Just narrowly, you see, 0.1 it is greater, but still it is satisfying. How about here? 2 plus 3, 5 greater than this. 3.2 greater than this. 4.2 greater than this. Okay, so we are done. Therefore, now let us see the way I have put these lengths. Let us see if the corresponding sides are in the same ratio or not. So here, what is AB upon DE? So I am writing here AB upon DE is equal to, AB is 1 and DE is 2. It is 1 by 2, right? Then what is AC upon DF? AC upon DF. AC upon DF is 1.5 upon 3. But this is 1 by 2 because if you remove the point 15 upon 30 it becomes. So it becomes. Then the last one is BC. BC upon EF. Now what is BC? BC is 0.6 and EF is 1.2. So remove the points, it will become half. So therefore we have now, you see, this half, this is also half we have, and here also we have gotten half. That means we have the ratio AB upon DE is equal to AC upon DF is equal to BC upon EF, right? Because all are equal to half BC upon EF. So now we have the second condition, the corresponding sides are in the same ratio is proved because all of them are equal to half. So second also it is satisfied. Now can we say these two triangles are similar? Yes, definitely. So now I will say triangle ABC similar to, this is the symbol for similarity. So triangle ABC similar to triangle DEF. Okay. So I hope you understood now the definition of similar triangles.